and welcome to Mathematics Illuminated, where I shed light on any and all math topics from simple to advanced in a way that is easy to understand and interesting to learn. Please subscribe to my channel as I continue to post more videos, and comment below on videos you would like to see in the future. Today I will be going over the Fibonacci sequence, which plays an interesting role in mathematics by helping to define the golden ratio. First, we'll take the two first given numbers of the Fibonacci sequence, 0 and 1. Then we'll add them together. This gets us our next number in the sequence, 1. Then what we'll do is we'll add the last two terms of the sequence together. And this gets us 2, the next number in the sequence. The way the Fibonacci sequence works is you add the last two numbers to get the next number. Here we get that 1 plus 2 is 3. Then we get that 2 plus 3 is 5. And we can keep going with this. Now we have the Fibonacci sequence, which extends infinitely. These are only some of the terms. The concept behind the Fibonacci sequence is simple, but it has some interesting properties. The golden ratio, or as known by its Greek representation phi, is a famous number that can be approximated using the Fibonacci sequence. I have part of the Fibonacci sequence on the left. You can approximate the golden ratio by dividing a term of the Fibonacci sequence by the previous term. Let's evaluate this as we get to larger numbers on the Fibonacci sequence. Doing this with the first terms isn't very helpful, since 1 divided by 0 is undefined. Doing this with the second terms gives us 1. Let's see what happens when I continue. We can see it approximating to 1.6. Now we can see it approximating to 1.618. If we keep doing this with more terms of the Fibonacci sequence, we get an even greater approximation of the golden ratio. So, what happens when we do this? We find that the golden ratio is approximately equal to 1.61803398887. Interestingly enough, the golden ratio is exactly equal to half of the square root of 5 plus 1. Additionally, it has the interesting property that the golden ratio squared is equal to the golden ratio plus 1. It is possible to use the quadratic formula to solve for phi here by rearranging the terms to make a quadratic equation. If you want to know how this is done, check out my video on proving the quadratic formula. So, where are Fibonacci numbers and the golden ratio used? They are used in geometry in constructions of a pentagon and a circle, and in 3D dodecahedrons and icosahedrons. They also show up in nature, such as in the petals of a flower. The amount of petals on a flower are very often a Fibonacci number, such as 3, 5, or 8. Additionally, the spacing of the petals often shows the golden ratio. The golden ratio is used in the study of human beauty as well, such as measuring proportions. The golden ratio is also commonly used in art and architecture, since many people find the proportions caused by the golden ratio to be visually appealing. Even the solar system uses the golden ratio when it comes to proportions between celestial bodies. And there are many more ways the Fibonacci sequence and golden ratio play a role in mathematics and life. Thanks for watching. If you thought this video was interesting, please subscribe. And if you would like a further evaluation on any of the topics mentioned in this video, leave a comment. Farewell for now.